those of you that used SQL I/O in the past, it is now deprecated. I'm in favor of disk speed, and I actually wrote a PowerShell wrapper for you that will help you automate those tests. It's free, it's here, don't even ask for your email address. Go check it out. If you like it, let me know. If you find bugs or have some improvements for it, let me know. Happy to take a look at it. But one of the things I want you to do is to test the storage at different performance levels, different test patterns, different block sizes, read, write, random and sequential, change up the intensity, change the block size, do 4K, 8K, 32, 64, even 1 meg, however you want to do it. But start to understand the performance characteristics of that storage as it's presented to you, because this matters, because what you see versus what the VM layer sees versus what the SAN admins see can be completely different. What you need, IOPS or IOs per second. You need latency measured in milliseconds, and hopefully if you're on all flash, you're measuring that in microseconds now, and then throughput in megabytes per second. The cool thing here, you can build a performance curve, and you can start to see what's going on with this environment. Now, you can break this up by read-write, random and sequential, and then worker intensity, and you can start to see how does the SAN respond to different kinds of workloads. Well, there's a problem here, and it was because we ran out of SAN controller cache. But if you're on all flash, this goes way up. It's pretty incredible. Now, you can do this and graph it not just by IOPS here, but by latency as well. And what you'll find is that you'll find a point of inflection where the latency will just shoot through the roof periodically when you hit some certain inflection point in the OS. And that can be a bottleneck in the interconnect infrastructure, it can be a bottleneck within the hypervisor, and it can also be a bottleneck within the operating system. So now that you have the ceilings, what do you do with it? Well, you take perfmon or whatever third-party utility you like. Measure the ongoing disk performance inside the VM. And now you can see, are we coming close to the capacity, the ceiling on performance, and not just space? And if you are, go talk to the VM admin. Why can't we get greater performance out of the VM? What are we doing? What's happening when we're coming close to that ceiling? Because if you don't have a lot of headroom there, it's not very good for scalability of the environment. Now, host architecture is interesting. This is a host. This is one physical server today. And there's stuff like this all under the public cloud as well. You got Rackmount servers, you got Blade servers. I've got a bunch of these in my basement right now. It's a lot of fun. These details matter. Intel versus AMD. Not going to badmouth any one vendor, but AMD, there's a core factor for licensing because the AMD chips just don't run as well as Intel. So keep that in mind. When you're shopping for this equipment, you want to look at sockets versus cores. We all know SQL Server licensing is core-based and not socket-based anymore. So a lot of times, the VM admin perspective is to buy the chips with the most cores, but they may buy slower individual core chips. You want to watch out for that. What I claim is that a lot of environments, you want faster chips that can process more in an individual core, and you may not necessarily want as many cores. I mean, your mileage may vary, your workload is very dependent on a lot of this, but SQL Server doesn't actively parallelize everything. And a 3 gigahertz CPU versus a 2 gigahertz CPU, it's a pretty big performance difference for normal stuff. Now, rated performance versus gigahertz speed, you got to remember that those are not necessarily equivalent. So check with a lot of the different benchmarks that come out for these CPUs and work with your infrastructure teams. If you don't have this ability to see this, you can pull what kind of CPU you have. Just download CPU-Z, fire it up, and the CPU architecture is presented to the guest. So you can see exactly what CPUs you've got, even if it's in a VM and you don't have direct access into it. Now, logical versus physical, I always want to count physical cores. I don't want to take hyperthreading into consideration. I do leave hyperthreading enabled when it's a VM, unless that host is running very, very busy, in which case I want to do testing to see if I'm actually going to get better performance by turning hyperthreading off. Normally I leave it on, but you need to test based on how busy you are. Now, CPU and memory get really interesting. There's this concept called a NUMA node. What a NUMA node is a long time ago. Let's say I had 4 CPU sockets back in the day, 1 core apiece, and say 32 gigs of RAM. That was a sweet machine. Well, that little red arrow there, everything from those CPUs had to funnel through some intermediary to get to memory. And eventually it became a bottleneck. So what they decided to do, AMD started it and I think Intel perfected it. What they ended up doing was splitting out the memory and putting 1 memory controller per socket and having a group of memory very, very close to each individual CPU socket. Now, one CPU can access memory from another NUMA node, as they call it, non-uniform memory access, but it's slower. There's physics involved, and it's actually about 3 times slower to go fetch that RAM because it's just farther to go through. So what you want to do here, let me show you an actual motherboard here. You can see this is a Supermicro motherboard, and it's actually got 4 CPU sockets, and if you notice, you take those middle blocks of memory and just split them down the middle. Each CPU has memory right next to it. One of the things to worry about here is how that memory is configured, and this is something that hardly anybody knows. Even the guys that sell you this, they don't know this. What happens if I fill up all the memory slots on this motherboard? Is it good? Is it bad? Is it indifferent? Well, your mileage may vary, but you need to spot check this. Common sense would tell you if I fill these up, I don't have to buy as large a capacity of sticks in order to get the quantity of RAM that I need. And if you fill them all up, it should be able to use them all and get a little bit better performance, right? It's not necessarily the case. This sheet right here shows you, this is off of a Cisco UCS B200M4, but the majority of Intel chipsets suffer from this. If you fill up the last bank of memory per NUMA node, it will actually declock the RAM down up to 33% in speed. That is transparent to your SQL Server. You will not see that from anything inside the VM, but because SQL Server is so dependent on RAM, that can actually be 15–20% performance hit on performance, and that's just not good. So take this grid here, do a quick bingo search of your computer hardware, physical machines, and go work with your sysadmins to go get this, and ask them what their memory configuration is like. It may shock you. So a quick way to go speed up the memory, if they've got extra just sitting there, pull out a couple sticks of RAM from the physical machine. And when you're planning to buy new equipment, take this into consideration. You might actually benefit by spending just a little more and get a lot better memory performance. Especially with VMs, it matters. Okay, VM architecture, our goal is to make sure that SQL Server suffers the least from the scheduling queue waits. How do we do this? Well, those resource limits, the maximums there, easy to detect, easy to work around. You know, if I've got 32 CPUs on a physical machine, we don't fill them up to 100%. Same thing with RAM. The queues are harder. Every millisecond spent in that queue is time lost from the VM, and stuff gets challenging at that point. Okay. These queues are also not necessarily first in and first out, and that's one of the bigger challenges there. If a VM suddenly gets really, really busy, the hypervisor can detect this and will actually let it cut in line. And some of these other things might actually get deprioritized and pushed to the background. And that's tough, because if your SQL Server is a normal SQL Server and it's not that busy, it might actually suffer immediately whenever somebody else runs something big. So now, the physical NUMA topology, 1 socket, X number of cores, and some associated RAM. What I want to do is I want to see if my SQL Server will fit inside of 1 NUMA node. So let's say that motherboard that we just showed, 4 CPU sockets, just pulling numbers out of the air, let's say 10 cores apiece, so 40 cores, and let's say 512 gigs of RAM. So 1 NUMA node, say 10 cores, 128 gigs of RAM. If my SQL Server will fit there or below, there's a good chance that I would actually benefit in performance by configuring it for 1 virtual socket and 10 virtual cores. Now I don't want to max out that SQL Server because I might need some background overhead for the hypervisor. But if I can fit it into 9 virtual cores, it works. Now again, it all depends on what you need. If you need, let's say, 16 cores, then it won't fit in one comfortably. So I would actually take the virtual configuration, split it in half, do 2 virtual sockets by 8 virtual cores. Because this way, you're minimizing the NUMA footprint, but you're going to maintain the performance. And don't take my word for it, test it. SQL Server is extremely NUMA aware and does a really good job of balancing the workloads. It's easy to test. You can see from the image on the screen here, I kid you not, it's like 5 clicks for a VM admin to change a CPU configuration. So you could turn it off, change the configuration, turn it on, do whatever testing you need with whatever you've got right now for baselines, long-running reports, anything that really matters. Turn it off, change configuration, do it again. And you'd be amazed at the performance differences you can get by setting this thing. For example, just a little bit of real-world testing from a while back. 16 VCPU VM. What's better? 2 virtual sockets by 8 virtual core, 4 by 4, 8 by 2, 1 by 16, 16 by 1. I've seen all of these. Well, standard DBA answer here is it depends, right? Depends on the physical machine, depends on the workload, depends on the VM version itself. If it's an older hypervisor, those matter more than some of the newer ones. So check it out. Cool thing is you can test it. Now this is a synthetic benchmark. This is not a real-world benchmark, but this is showing scalability inside a HammerDB test. And again, all we did was take the exact same database and just crank up the number of CPUs and change the configuration. And what you'll find is that based on workload, the performance characteristics are different. It took longer to graph this than it did to do the tests. You can do this yourselves. You can do it internally to whatever environment you've got. But do this because we need to make sure that this thing fits comfortably inside that environment. If it doesn't, change it. That's a big performance difference right there just by clicking a couple buttons to change a configuration. That's substantial. Now, CPU scheduling is one of those areas with the hypervisor that's not commonly understood, even by the system administrators managing this. And I've got some metrics here that really matter. They matter a lot more than a lot of VM admins think. And I run into some really interesting scenarios in different places as a result. One virtual CPU to one physical CPU is a poor recommendation. There's a lot of discussion online about, to be conservative and safe, do 1-to-1. And if you're looking at being absolutely conservative and absolutely safe, yeah, start here. But if you do this, you might not be taking the full advantage of that physical hardware, and as a result, your SQL Server licensing footprint goes up, which stings. So what I say is now, let's start to monitor the CPU scheduling queues to see what that performance impact actually is. Because I would claim that we can get away with at least a little bit of CPU overcommit and not even be able to measure it, let alone feel it. So in terms of the scheduling queues that we care about, there's first one is the amount of time spent in the CPU scheduler per virtual CPU. VMware calls this ready time. Hyper-V calls this CPU wait time per dispatch. They're measured in about the same way, and it's essentially the number of milliseconds spent in the queue per polling interval. So if it's that time spent in the queue, it's time not spent running. You need read-only access into either System Center or vCenter, whichever platform you've got, in order to go see this. Now, we don't have a good way to go get this inside public cloud providers right now, but this is where regular performance monitoring will really help you detect the anomalies there. So if you notice here, this is an 8 vCPU VM, and we have measured the millisecond latency every 20 seconds, and this screenshot came from a VMware system. Those measurements are milliseconds. So 28, 24, 46, 49, 39 were the last window that we care about here. Let me show you the actual scheduling impact of this environment. So nice and simple. Calc. Let's pick the biggest one on the screen here over the last hour. So 85 milliseconds 20,000 milliseconds in that polling interval, 20 seconds, times 100%. So absolute worst CPU overcommit in the last hour was a 0.425% performance penalty. That's pretty darn good. This came from an environment that had, at the time, 83 VMs on 3 hosts. Over 25 of those were big SQL Server VMs that were actively being used. And this is the kind of performance overhead you get from the hypervisor. That's stellar. It's phenomenal. I would claim we've got room to grow, and in fact, they did. They added another host recently, but only because we were out of RAM and not because we were out of CPU. These numbers are that good. So get access in your hypervisor because you need this kind of visibility. Easy to get to. Now, when I talk about VNUMA balancing, this was another screenshot from another environment that had a 16 virtual CPU VM configured for 1 virtual socket by 16 virtual cores. This was running on a 2 socket by 10 core physical machine. Well, the VM didn't fit properly, and the VM was fairly busy. So if you notice, the latencies here, 979, 977, 878, 1, 1, 2. Half of the vCPUs in that VM were hitting essentially a 10% performance penalty. The other half were basically real time, no delays. And as a result, because they had maxed ops set to 0, everything in that SQL server was now 10 to 20% slower. And we went in and we reconfigured the VM for 2 by 8 instead of 1 by 16, turned it on. Yeah, CPU readies were perfectly fine after that. Performance went up by about 20, 25%. Life was good. Easy to detect if you have access to this layer. And I stress, get access to this. There's a blog post on my blog that gives you some of the talking points for how to go get into it. Now, there's one more here, and I have not found an equivalent inside Hyper-V. It's called Co-Stop. And if anybody out there has got the equivalent inside Hyper-V, I will buy you a nice supper at the PASS Summit later on this year. And you can hold me to that. What Co-Stop is if the hypervisor detects that the operating system needs to run something in exact parallel on multiple threads, or that the hypervisor CPU schedulers are a little out of balance for all vCPUs on a VM, it'll actually pause some of the vCPUs to let the others catch up. And ordinarily on a normal environment, you might see a blip of 1 millisecond, maybe once or twice an hour. What happens here is that these things can bury you. From a host CPU perspective, what most things monitor, this machine, this physical machine, was running less than 5% CPU busy, but our Co-Stop numbers here, 300, 400, 500 milliseconds, were so bad we were looking at over a 95% performance degradation on this particular machine. That's really, really tough. Easy to detect, easy to identify if you've seen it and if you've got monitoring set up for it. Right now there's only 1 or 2 third-party utilities out there that can actually collect this, but knowing what to do with it is a bigger battle. This VM in particular, they had fired up another VM that was very wide and misconfigured with VNUMA in the background, and it actually caused this on our SQL server. So no changes on the SQL server, and this happened. It's pretty scary. So again, this is a VMware only counter. If I can get one on Hyper-V, I'd be really, really happy. Okay, so we need to reduce the footprint of the VM, maybe, or we might need to give it more CPUs, maybe. I'm sure your VM admins are coming to you and saying, you're not using all the CPUs, you're not using all the RAM. Well, that's not always true. The visibility that they have into the VM layer shows what the VM layer sees, but it's not application aware. It doesn't know what SQL Server is doing with the RAM or doing with the CPUs. So it's a difference of opinion. We need to figure out what the right amount of CPU is for the VM now, because that's what we need. We don't necessarily have to worry about oversizing this thing like we do on a normal physical machine. So we got to give it the right amount. We need to do it for now. We can always turn this thing off and add more, You know, if you need to go down the hot add road, there's some limitations with that, but you can still hot add resources as needed down the road. Idle CPUs, because of the CPU scheduling, can not only slow down your VM, it'll slow down those around you. It's not good, so we've got to size it for now. It's a right-sizing analysis that really matters, and this has to do with performance characterization and classification of your machine by workload period, by day of the week, by hour of the day. You know, where are we at with our maximums? Where are we at steady state? Can we disregard things running on the weekends because it's the weekend and we don't care, the business is down, you know, that sort of thing. So you got to really watch out for that. Whew, there's a lot of stuff. So now, storage at the VM also matters. What happens if I have, let's say, 10 virtual disks, 10 LUNs, and it's all connected to one SCSI controller? It's kind of tough. I like to spread this out. Windows will actually do queuing by SCSI controller and not necessarily by drive. So if we give this thing more paths out of the VM, we can spread out that workload a little better. I want multiple virtual disks whenever you can. A lot of VM admins go so far as to say, it's the same SAN underneath. Why do you need more than one virtual disk for all of your SQL Server databases? Well, I'm working on some research right now to prove it. And you know, I hope to have those white papers out here in the next couple of months to demonstrate why you need a lot of this stuff. You know, I can tell you you do. You can test it for yourself, but I want that objective proof there. I want multiple SCSI controllers. The disk configuration that you see here, this is kind of the way I start. You got a normal drive for C drive. I'll actually talk about that here in a second. If you are on VMware, you do want to leverage the Paravirtual driver when you can. It's free. It basically gives you a greater queue depth and a little bit better performance to disk. Again, it's free. It comes with it. There's another blog post that I've got out there about how to retrofit an existing VM with the Paravirtual driver. So my disk layout, this is a starting point. This is not the end point. Your environment may be different, but I like to split stuff up as much as I can. So I split out the OS from the SQL Server installation, and I do that particularly because I may want to actually have snapshots on the OS that I don't want to apply to SQL Server, and I can selectively choose what disks I want to do that with. And that way, if an OS level patch blows up, I can roll back very quickly, but I don't lose any of the transactions that have come in. If I'm doing heavy replication of system databases, I may want to have a separate disk for master model in MSDB. So AGs, replication, things like that that hit MSDB pretty hard, I probably want to split that up. I'll have one or more disks for my user database data. I'll have one or more disks for my user database logs, depending on my workloads. I definitely want to at least split out tempdb. Now, depending on my workload of tempdb, I may keep the logs here. I may add another drive for my logs. Doesn't matter. You got a lot of drives that you can add. And if I'm doing heavy SAN to SAN replication, it might make sense for me to move my page file to another drive, and then I place that virtual disk on a SAN line that is getting replicated less frequently, and that way I can save a lot of that bandwidth. And if I'm doing local backups, then I'll have a separate drive for that, and that way I can back that up with whatever imaging software you've got, and it can offload a lot of that and get it out of there. The OS, 64K NTFS block sizes is what Microsoft has recommended for years, and I endorse that. If you are on all flash, I want you to test 8K block sizes versus 64. Your mileage may vary, but you might find that an all-flash SAN responds better to an 8K block. Again, test it. You've got disk speed, you've got SQL Server, you've got any of the latency counters within Windows. You can go test it pretty easily. Windows, I want to make sure my power settings are set to high performance. Same thing with the physical machine inside the BIOS and at the hypervisor. I want to make sure that those are set to high performance. SQL Server, it matters. You're going to get a little bit better performance, and that way it doesn't have to deal with trying to scale up and down those CPUs. CPU-Z can actually show you where it's running at. There's actually a perfmon counter inside Windows. It's like processor information percentage of maximum frequency. It can tell you right now if you're not running at 100% max. So you can go check that out pretty easily. Antivirus exclusions for SQL Server, by all means. I want to keep the footprint of all activity down inside that VM, so knock that out. It's easy to do. The recommendations have been around forever. It will still bite people. Ongoing OS level performance metric collection is something I completely just mandate. You have to know what's going on. And if something was, quote, running slow last night at 5 o'clock, usually somebody's not going to call you at 5:01 and say, the C drive on this database server is running slow. Can you help? It's always, it's slow yesterday. What was wrong? So getting a lot of the ongoing performance metrics here will help you at least give you some data on what was going on. And if you can aggregate a lot of this across the environment, you can start to see what was going on there and what impact did it have here. And I've actually been working with a third-party company at the VM level to try to detect some of those anomalies. And if you're interested, message me and I'll get you in touch with them. It's pretty cool stuff. So if you don't have a third-party utility out there that measures this, go to the link on the site there. I tell you how to set up perf monitoring. It does matter. You do want to start to collect a lot of that stuff. Now, the SQL Server side plays into the VM configuration and the physical machine configuration really, really tightly. And these are areas that the VM admins don't know that you can do. And if they have their end set up right, you can leverage these to get an even bigger bang for the buck. Everything inside SQL Server is subject to parallelizable workloads. So what do we have at our disposal to figure out what's going on? Well, you've got the max degree of parallelism, which is essentially the maximum number of CPUs that you can parallelize a workload on. Now again, these are starting points for where to start testing. This is most certainly not the end point. But you can start to say, should I make it a rule with this workload to set my max stop number to the same number of virtual cores that's in one virtual NUMA node? So if I've got a 16 VCPU VM and I've got a 2 virtual socket by 8 virtual core setup, the NUMA node is 8 VCPUs. So you might want to start your testing at 8 here. Again, test, test, test. Every workload is different. Every SQL Server installation is different. It matters. Now, the other one here is, now that we've set how many CPUs you can parallelize against, at what level of parallelization execution cost do we start to try to parallelize? The default value is 5. There's no metric to this. It's one of those, I always tell people, don't leave it default. But don't just pull a number out of thin air and say, this is what we're going to use. A lot of folks out there say 50. A lot of folks out there say 25. I like to be objective and scientific about it. Either 50 or 25 is a starting point for testing. But Jonathan Cahias actually has a great query out there for how to tune the cost threshold for parallelism by actually looking at these cost values out of all the queries that are stuck in your plan cache. Easy to go run the query, takes a couple minutes to run on a busy system, and you start to get all these cost values. Now you can take that and you can run it into a scatter plot in Excel or Power BI or whatever you want to look at, and you can start to see logical groupings. And what happens now if you find that the cost threshold is set too high? For example, one environment a while back, the medical ERP system, their company was saying you have to have cost threshold set to 50. We're going to let you parallelize, but you need to set it to 50 and we won't support you unless you don't. Well, this one environment had 62,000 queries in their plan cache. 6 of them were above 50. And they were ones that were run once a month. So essentially, by setting the cost threshold for parallelism at 50, they had essentially eliminated parallelism. So we went in and we ran this query and went and looked at it, and 95% of their queries were between 5 and 10. And we went and did some testing, and what we were finding is that as we went down in the number, we were able to get the bigger ones to benefit from it, but leave the rest alone. So in that particular environment, we were actually doing a cost threshold of 9, and we were getting the best bang for the buck where we weren't flooding the system with these big parallelized requests because it was a highly concurrent system, but we got the best performance for the stuff that needed it. So be scientific about it. Doesn't take that much time to do. The database itself, we already talked about spreading out the I.O., but that was from the virtual disks. Well, the same thing matters here. SQL Server can bottleneck at the database I.O. level. So if you've got a lot of archival data or a lot of commonly joined tables, you can have more file groups, more data files, and let SQL Server better parallelize. This is why we do this with TempDB. You ought to look to do this with some of your bigger databases. We can even partition there and get better optimization there if you're on enterprise. Parallelism here on multiple virtual disks also helps you with active paths to storage both through the hypervisor and directly to the SAN. So you spread it out here and you're going to get lower latencies as seen within SQL Server, even before it gets to Windows. It's pretty cool. So reducing the I.O. is another big one. I can do table compression, I can do index compression, but you need to watch out. You need to ask your storage team, is my SAN doing some sort of data savings today? The problem here is if you enable compression and index, table and index compression inside SQL Server, if the SAN is already doing this, you actually just hurt them. It's actually going to slow down the SAN, and it can potentially be writing more data by trying to compress it and save it inside SQL Server. So work with them and see where the best trade-off and balancing act there is. In-memory constructs are great if you've got the need, if you've got the app that can be modified to deal with whatever limitations you've got with it. It's powerful stuff. You're still dependent on storage speed here because of logging, but if you can leverage this, do it. It's great. More RAM, I hate to say throw more hardware at it, but sometimes we just need it. But you can prove it. Look at buffer cache hit ratio. Look at page life expectancy. Look at the physical machine to see if you're under memory pressure at any given time. You can go see this. SSDs for read and write caching, or potentially, an all-flash SAN. This stuff matters, and especially when more and more things are leveraging the same storage, it adds up, and it adds up quickly. So finally, you've gone through the virtual layer, you've gone through the hardware. Now you can actually get to what the DBA is supposed to do and work with the developers to clean up the bad data model, improve the maintenance, deal with bad queries and bad procs, all this stuff. But you got to get the infrastructure out of the way. The biggest thing is I don't want the infrastructure to hold back the SQL Server at all, be it physical or virtual. There's some tuning that you can do at the virtual layer to really relieve some of those artificial bottlenecks, but at the end of the day, I want the code and the data itself to be the bottleneck. I don't want the infrastructure holding you back. And I can claim with a straight face that you can virtualize just about everything, and if you make it more efficient in the way it's stored and retrieved, that sets you up for going to public or hybrid cloud whenever the time is right for you. So what questions do we have?
All right, David, we got several here. What is the impact of vMotion or the Hyper-V equivalent on the noisy neighbors syndrome? Does the vMotion have more negative impact than the noisy neighbor syndrome?
That's a really good question to whoever asked that one. So VMware calls it vMotion, Hyper-V calls it live migration. For those of you that don't know, that is the act of relocating a running virtual machine from one physical machine to another. The impact of this is honestly better. The noisy neighbor bit is more of an ongoing problem for minutes at a time. If you trigger a vMotion or a live migration to move your VM to a less busy host, you do have a very small performance hit for about 1 second, give or take, while the hypervisor, quote, stuns the VM as it finishes up the move. I claim that that little stun operation is a whole lot better than having to deal with a big performance penalty from a noisy neighbor for minutes or even hours. So I would do it. I would definitely do it in a heartbeat.
Okay. Raymond put in there, he said, please include the store port drivers in your white paper. It is a single queue per physical drive.
Cool. I will do that. It's something I'm still working on getting the testing down there. But yeah, the Windows updated store port driver. That's a good one.
Okay. How can we improve the CPU signal weights for SQL when virtualized?
That's another good question. A lot of times, well, first of all, are the weights that you're seeing with CPU weights, is that a bad thing? And to quote Paul Randall, I don't want to have a knee-jerk reaction to CX packet when it might not necessarily be a problem. That said, a lot of times it is, and that comes down to tuning cost threshold and max stop and taking a good look at the queries that are contributing to the high CX packet weight. A lot of times if the VM latency on the CPUs is high, you're going to see high CPU ready and or high CPU Co-Stop or wait time per dispatch on Hyper-V. So what I would do is I would take a really good look there and just make sure that, one, you're actively using all the CPUs that you've assigned it. If you've got 16 CPUs and your absolute highest CPU usage during the day is like 8%, I would claim you can probably get away with less CPUs. Cut that footprint down, watch how the system rebalances, make sure you get the VNUMA configuration right, and then if the CX packet weights are still high, then dive into it that way from a query perspective and cost threshold and max degree of parallelism, both of those.
All right. What are your favorite perfmon counters to be run and collected from the VM?
Ooh, that's a good question. I've got the full list out at the perfmon guide at my company website, but the ones that I really care about are going to be CPU consumption by core, disk IOPS throughput by drive or mount point. I want to know memory pressure, so free memory, active or available memory. I also want to know if my host is forcing ballooning down, and both Hyper-V and VMware are subject to this. I want to know page file percentage to see if I need more memory from a Windows perspective or not. I also want to see C1, C2, C3 time at the CPU level to see where we're at with NUMA lookups. Those are the big ones. Those are the ones that can really help you tune the VM configuration itself. And potentially even the host to get the more power out of what you already own.
Okay. Is there a way to tell if too much memory has been allocated to SQL Server and can be reclaimed?
Mm-hmm. Yeah. Biggest thing here is going to be looking at the active memory counter inside Windows. If we've got a huge amount of active memory or available memory that's free always, it's easy to trim that. Inside SQL Server, I want to look at a combination of page life expectancy by NUMA node. I want to look at buffer cache hit ratio. I want to look at all kinds of stuff. But, there's that. There's a number of the memory settings. I want to put them all together. I don't want to look at just one. But if my buffer cache hit ratio never drops 39%, if my page life expectancy at its absolute lowest per NUMA node still has, still is at 150,000, I would claim with a straight face that you could definitely trim some of the fat there with the memory and keep the performance equal to where you're at today.
All right. How can we get the various information on the actual usage of the CPU and the time it took to assign of the VMware VMs when you do not have access to vCenter? I'm like going.
You got to get access. Okay. The official stance is you got to get access. Same thing goes for Hyper-V. You really do need at least read-only access into your hypervisor management system. Now, that said, in a lot of cases, that's easier said than done. So if you email me or message me, if you have access to the vCenter database, I can send you some queries that will help you mine that information out there. Now, you're the DBA. You need access to that stuff. And if they won't give you front-end access to it, you need it in order to do your job better or to at least rule out that the hypervisor could be suspect in a performance problem. So I give you the ability to go behind them and go get access to the database. Because you're the DBA, you need to go get access to the database for maintenance, right? So, might as well go do it.
Yeah, go buy some beer or wine or whatever and go sweet talk them. Chocolate. Figure out if they like chocolate, so.
That's the biggest thing. I mean, I like to go through the official route. You need access to it. I've got a blog post out there that gives you a lot of the talking points. You need it to do your job better. If they still won't give it to you, honestly, contact me. I'd be happy to get on the phone with whoever from your organization to really help convince them. It doesn't hurt them at all. It actually helps them because now you're not going to go finger pointing at them anytime there's a performance hiccup at all. You can just spot check there and see, oh yeah, that's fine. We'll keep on digging to look for what else we've got. So it's really in their best interest to give you access to it.
Okay. This thing is jumping, so let me see if I can get to stop jumping here. How can I prove hyperthreading is a bad thing for my virtualized SQL environment? It makes me purchase an additional SQL Server license. That's the comment.
Yeah, I mean, if hyperthreading, how can you prove that it's bad? The easiest way is if you have ongoing benchmarks and baselines that show the performance of routine tasks, turn it off. It's that simple. Turn it off and validate the performance before and after. You'll be able to see this within the hypervisor pretty easily just with regular CPU consumption. But I mean, it is as simple as get your baselines, turn it off, and see how things settle in.
Okay. What is preferred in a VM? Connecting to SanDisk via iSCSI or using map points in a NetApp SAN?
I would still claim a virtual disk there will be more beneficial to you than having to deal with storage presentation both at the virtual machine hardware layer and at the in-guest layer. It gives you more flexibility unless you're doing traditional SQL Server clustering. If you were doing traditional SQL Server clustering, you would need the in-guest iSCSI on a NetApp. That said, if that's not the case, I would urge you to do virtual disk and let the hypervisor deal with the storage presentation.
Okay. Do you always recommend configuring storage for SQL per the vendor documentation, assuming it is available? I tend to want to configure per the doc so that the vendor does not tell me to reconfigure if I call for a performance problem.
I agree. I would say the majority of the time I say yes, configure the SAN for their recommendations. However, if their recommendations are poor and you have tested and documented the differences and seen a measurable and noticeable improvement with your altered configuration, I would go with yours. Otherwise, I would go with theirs. But you need to be able to demonstrate that we maintain availability, we maintain stability, and we increase performance by doing it our way instead of their way. I'm not going to name any vendor names here, but there are a couple out there where I just don't like their documentation, and there's better ways to do it.
Okay, how much CPU over provision do you recommend with or without hyperthreading? With and without hyperthreading.
Okay, well, I generally look at over provision and I exclude the logical cores from the calculation. So I would claim anywhere from 1.2 to 1.5 times the vCPU count to the physical CPU cores is a safe bet. You'll need to test, of course. And in some cases, I'll go higher. I've got some cases where the workloads are very, I don't want to use the word small and light, but the VM footprint is smaller and the VM activity is moderate to light. And I can get away with 2.5 to 1, maybe even 3 to 1 in some environments. But to be safe, roughly the 1.2 to 1.5, that's where I find most of the VMs fall into pretty comfortably. Again, you got to test it. You got to watch the wait time per dispatch or ready times there to measure it. But I would claim you can comfortably get away with that most of the time.
And here's one wants to know, what is the most interesting performance issue / problem that you have worked on with SQL and VMware?
Oh, that's a fun question. Okay, one that I've seen numerous times. All flash array, virtual layer, Hyper-V or VMware, it doesn't matter, in guest. SAN is reporting storage latency no greater than 0.8 milliseconds. Inside SQL Server, one in particular, we saw latency as SQL Server saw it at 108 second max. And both the SQL Server team and the SAN team were right.
Cool. All right. Let's see. Do you have a link, David, to your blog? I see, your Twitter and those type of things. But do you have can show us the link to your blog? Because some people are
Oh yeah,
asking.
just right there, just davidklee.net. And then I've got some of the how-to docs out at heroflux.com. It's under the knowledge section there.
Okay. All right. So guys, that's where you get the information. Someone was asking about that to get that access to vCenter.
Cool. Yeah, and again, feel free to message me. Again, I really want to help. I've been a DBA, and a VM admin at different places that I've worked at over the years, and you do need access to it. And sometimes it takes somebody from the outside explaining why. So if I can help you get access to it, let me know, and I'd be happy to follow it up with a little bit of training to show you what you're looking at there and how it applies to your SQL servers.
Okay. All right. Well, David, it's about time here. We appreciate again you being with us. We're always thankful because you do such a wonderful job and have such a vast knowledge on virtualization that we love having you with us.
Thank you.
We'll get you scheduled out here later on in the year to have another question and answer. So you
Cool.
guys be thinking about your questions and answers because that one's free flow. We basically don't have a presentation. You bring your questions and we'll get them answered by David. So we'll look at
Awesome.
that toward the end of the year. So Rick Clayton, you are the winner today of the $100 gift card. I'll be sending you an email here shortly. And I will be getting this recording out there on YouTube hopefully within the next day or so. I'll be sending an email out with the information, and we'll get David's slides and we'll post them up on the virtualization.sqlpass.org website. I did send everybody, if you're going to Pass Summit this year, there's a $150 discount code. I chatted that out to everybody. If you need it and you plan on going, hit me up if you don't have it. And at virtualization at sqlpass.org is the email address, or armordba@gmail.com, and I'll send you the link there. Looking forward to see you there, David, of course, and I'll be there, of course. And anyway, thanks again, and have a wonderful day and enjoy the weather. Thank you.
Oh, thank you. You too. And I'll see everybody at the summit this year. So you
Okay.
better be there.
All right. Bye-bye, everybody.
Cool. Bye, everybody. Thanks again.
We had almost 100, David.
Wow, that's awesome.
Yeah, 10. So it was 93 that actually attended and stuff, so, of the group.
That is so cool.